Water, the elixir of life, isn't always crystal clear. Sometimes it's cloudy, murky, or even downright muddy. This cloudiness, known as turbidity, is a telltale sign of suspended particles like silt, clay, and microorganisms lurking within. These particles can come from various sources, from natural erosion to human activities like construction and agriculture. Measuring turbidity is crucial for understanding water quality. High turbidity can impact aquatic life, clog pipes, and even harbor harmful bacteria. That's where the Jackson Turbidimeter, a time-tested tool, comes into play. This ingenious device helps us quantify water clarity, providing valuable insights into the health of our precious water resources. So let's dive in and explore how this simple yet effective instrument helps us unravel the mysteries hidden within murky waters. Imagine trying to quench your thirst with a glass of cloudy water. Not very appealing, right? That's why monitoring turbidity is essential for ensuring the safety and aesthetic appeal of our drinking water. Developed in the early 20th century, the Jackson Turbidimeter might seem like a relic from a bygone era. However, its simplicity and effectiveness have kept it relevant even in our technologically advanced world. This ingenious device relies on the scattering of light to determine the cloudiness of a water sample. At its heart lies a graduated glass tube, the stage where the turbidity drama unfolds. This tube, marked with units, holds the water sample under scrutiny. A candle, the light source of this rudimentary yet effective setup, sits below the tube. The star of the show, however, is the steel tube, housing a lens at its base. This tube, adjustable in height, plays a crucial role in determining the turbidity level. Complemented by a stand that holds everything in place, the Jackson Turbidimeter, despite its simple design, is a powerful tool for assessing water quality. Don't let its old-school vibe fool you. The Jackson Turbidimeter is still a valuable tool for assessing water quality in various settings, from environmental monitoring to industrial processes. Turbidity measurement using the Jackson Turbidimeter hinges on the principle of light scattering. Imagine shining a flashlight through a clear glass of water. The light passes through effortlessly, barely hindered. Now, picture doing the same with a glass of muddy water. The light beam scatters, its path disrupted by the suspended particles. This scattering effect is the backbone of the Jackson Turbidimeter. As light from the candle travels through the water sample, suspended particles cause it to deviate from its straight path. The more turbid the water, the more pronounced the scattering effect. The Jackson Turbidimeter capitalizes on this phenomenon. By adjusting the height of the steel tube, we can determine the point at which the light's image from the candle disappears due to scattering. This critical point, measured on the graduated glass tube, directly correlates to the water's turbidity. The units of turbidity measured by the Jackson Turbidimeter are called Jackson Turbidity Units, J.T.U. These units provide a standardized way to express and compare water clarity across different samples and locations. Measuring turbidity with the Jackson Turbidimeter might seem daunting, but it's straightforward. Follow these steps to become a turbidity testing pro. First, collect a clean water sample. Next, place and light the candle. Pour the water into the graduated tube. Slowly lower the steel tube. Lower until the candle flame disappears. Note the level where the flame disappears. This is your turbidity reading in J.T.U. Section 5. Table Talk. Deciphering the turbidity code. The Jackson Turbidimeter provides turbidity readings in Jackson Turbidity Units, or J.T.U. However, you might need to convert these readings to other units, such as nephelometric turbidity units, or N.T.U, for specific applications or comparisons. Light path, MMR, turbidity, J.T.U, 200.0, This table helps you convert the light path length, measured in millimeters on the graduated glass tube, to corresponding turbidity values in J.T.U. Section 6. cleanliness is next to clarity, ensuring accurate readings. In the realm of turbidity measurement, cleanliness reigns supreme. Even the tiniest speck of dust or a lingering fingerprint on the glassware can spell disaster for your readings. Why? Because any foreign substance can scatter light, throwing off the delicate balance the Jackson turbidimeter relies on. Before each measurement, treat your glassware with the utmost care. Thoroughly wash the graduated glass tube and the steel tube with distilled water and a mild detergent. Rinse them meticulously to eliminate any soapy residue. Once clean, handle the glassware with gloves or by the edges to prevent oils and dirt from your skin from contaminating the surfaces. Store them in a dust-free environment to maintain their pristine condition. Remember, a clean turbidimeter is a happy turbidimeter. By adhering to strict cleanliness protocols, you can trust your turbidity readings to be accurate and reliable. Section 7. Position perfection, finding the sweet spot for measurement. The Jackson turbidimeter might seem like a simple device, but even the slightest misalignment can skew your results. Accurate readings depend on precise positioning of the candle, the graduated glass tube, and the steel tube. First and foremost, ensure the candle sits directly beneath the center of the graduated glass tube. This alignment ensures the light travels through the water sample uniformly. Adjust the candle height so its flame is at the same level as the zero mark on the graduated tube. Next, pay close attention to the steel tube. As you lower it into the water sample, keep it perfectly vertical. Any tilting can alter the light path length, leading to inaccurate turbidity readings. Think of it like a delicate balancing act. Each component of the Jackson turbidimeter plays a crucial role, and their precise positioning ensures reliable and repeatable turbidity measurements. Section 8. Interpreting the results. What does your water reveal? Once you've mastered the art of the Jackson turbidimeter and obtained your turbidity readings, it's time to decipher what those numbers signify. Turbidity, often expressed in Jackson turbidity units, or J.T.Us, provides valuable insights into the water's clarity and overall quality. Generally, lower turbidity readings indicate clearer water with fewer suspended particles. Higher readings, on the other hand, suggest murkier water laden with suspended matter. But what constitutes good or bad turbidity depends on the context. For drinking water, turbidity levels should ideally be below 5 J.T.U. Higher values can affect taste and odor, reduce disinfection effectiveness, and even pose health risks due to potential harboring of pathogens. Remember, turbidity is just one piece of the water quality puzzle. Other factors, such as pH, dissolved oxygen, and the presence of specific contaminants also contribute to the overall picture. Section 9. Troubleshooting tips, conquering common turbidity testing hurdles. Even with the best intentions, turbidity testing can sometimes throw a curveball. Here are a few tips to help you overcome common hurdles and ensure accurate readings. Difficulty determining the exact point where the candle flame disappears. Slowly raise and lower the steel tube to confirm the reading. Dimming the lights can enhance visibility. Fluctuating turbidity readings during measurement. Ensure the water sample is well mixed. Avoid vibrations that could disturb the sample. Consistently high turbidity readings despite using clean glassware. The water source might be highly turbid. Consider filtering or diluting the sample. Patience is key. Section 10. Beyond the turbidimeter. Other methods for measuring water clarity. The Jackson turbidimeter, while a valuable tool, isn't the only method for measuring water clarity. Technological advancements have led to the development of more sophisticated instruments, such as nephelometers and spectrophotometers. Nephelometers utilize a light source and a photodetector positioned at a 90-degree angle to measure the intensity of scattered light. This method, known as nephelometry, offers greater sensitivity and precision compared to the Jackson turbidimeter. Spectrophotometers, on the other hand, measure the amount of light that passes through a water sample at specific wavelengths. By analyzing the absorbance or transmittance of light, spectrophotometers can determine turbidity and other water quality parameters. The choice of method depends on factors such as the required sensitivity, accuracy, cost, and availability of equipment. While more advanced instruments offer greater precision, the Jackson turbidimeter remains a valuable tool for basic turbidity assessments, particularly in resource-limited settings. The enduring relevance of turbidity measurement. From the Jackson turbidimeter to sophisticated electronic instruments, the quest to quantify water clarity has captivated scientists for over a century. Turbidity, a simple measure of water's cloudiness, holds profound implications for environmental health and public safety. Understanding turbidity measurement gives us insights into suspended particles in water. These insights help us make informed decisions about water treatment and pollution control. Embracing both old and new techniques ensures clean, safe water for future generations.